So there's one more topic I want to talk about related to the overview of Project Reactor, and this is something called the AsyncTaskBarrier framework. And the AsyncTaskBarrier framework is actually something I created, and I use this for the test cases for reasons we'll talk about in a second. And this framework provides an API to register either blocking or non-blocking task methods that can either run asynchronously or synchronously. And there's two implementations of this, one for Project Reactor and one for RxJava. And that's because there's ever so subtle differences between the types of classes that Project Reactor supports versus RxJava. And so I had to make them sadly be slightly different. So what is this framework about? It's a framework that allows applications, in our case, largely test programs, to register tasks and run tasks either asynchronously or synchronously to ensure that the calling method doesn't exit until all the asynchronous processing completes. And you can see here from this class diagram that we have two static methods, and we define these methods as static just for the convenience of our test driver. So we can just say AsyncTaskBarrier.register, AsyncTaskBarrier.runTasks. If I was building a production system for application use as opposed to test driver use, I might actually have this be non-static methods and make instances of AsyncTaskBarrier. So your mileage may vary, and you would have to decide if you wanted to do that if you change this to work for something else. So why do we need to do this in the first place? Well, the test methods we're going to be showing through our case studies are largely, not exclusively, going to run asynchronously using the subscribe on concurrency operator. And what that does, as we show here, is it tells Project Reactor to run this mono or flux in a background thread. Now, one of the consequences of doing this in a background thread is that the methods can return, like this test fraction reduction async method, can return with a mono to void, we'll talk about that later, before the actual computations that they're running complete, because we've scheduled them to run in a background thread. And these asynchronous methods, if we don't handle them properly, can cause chaos and insanity if the main thread of control exits and all that's left are a bunch of background threads, which are so-called daemon threads. Because if a main thread exits and there are no more user threads left, it will automatically kill off all the daemon threads, which would be completely antithetical to what we're trying to achieve here with our test cases, because we want to run a bunch of things in the background. So let's take a look to see how this might apply, and I'll show you why it can be very helpful to have a single location in our main driver program that's going to wait for all the asynchronously executing test methods to complete. So here's our main method in some test program somewhere. And what we can do is we can use the AsyncTaskBarrier class to register, in this case, non-blocking task methods that are going to run asynchronously. So we're going to register the test is prime timed and test is prime async methods with the AsyncTaskBarrier. So we register them. So now the task barrier is aware of those methods. By the way, we can also register synchronous methods if we want. We also have some examples where we just show how you can do things synchronously. That also works. It's not as interesting, but it works. Let's say, for sake of argument, that we use things asynchronously, though, asynchronous methods, so they run in background threads. When we call the run tasks method on the AsyncTaskBarrier, that will go ahead and start up all those asynchronous registered methods to run concurrently in background threads. That's what I'm kind of showing here with the little gerbil wheels. Everything's running in separate threads. And we have a couple of choices. We could either wait reactively for this, or, as is the case with our test programs, we block. So we call the block method. This is a block method called on the mono that's returned from run tasks. And this will then block the main thread until all those asynchronous tasks finish, at which point the main thread can finish too. So this block call is playing the role of a barrier synchronizer, which is used to wait for a bunch of other things to either start or to finish. So that's what a barrier does. We will take a closer look at the AsyncTaskBarrier's implementation details after we cover the Project Reactor flux operators in more detail in upcoming lessons. If we looked at them at this point, it probably wouldn't be very interesting because we haven't really talked about all the different features we're going to discuss here when we talk about fluxes and monos throughout the rest of the lessons. So we'll cover this later when the time is right. So that's the end of the overview of the async task barrier framework in Project Reactor.